Welcome to the fourth of the SRE sessions. I'm glad that we've got a little bit of room today. I gave a presentation yesterday where we had 800 people registered for a room that fit 400. And there were, justifiably so, an awful lot of upset people who were happy to leave their opinions about the lack of space in the room. So I'm happy to see that we've got plenty of room here to be able to talk through growth and scaling. And for this whole track, what we've really tried to focus on is the operational side of the experience and how we can bring some of the SRE-focused disciplines into operating in a public cloud environment, in particularly operating in an Azure environment. What we're going to talk about today is kind of on its face pretty simple. Right? How do we take an application? How do we take a VM? How do we take an instance? And how do we scale it? What are our options? How do we do it? We're going to look in the Azure portal. We're going to look at ARM templates. We're going to kind of go through the basic blocking and tackling of here's what we do and here's how we do it. The bigger picture, though, is we're going to ask a lot of whys. Why would we use this type of scaling instead of that type of scaling? Why do we need to know specific types of information about our application or about our environment or about our deployment in order to be able to make these decisions? Why do we want to pay for some of the options that we have, or do we want to pay for some of the options that we want to have? So I'm hoping that this will be a good mixture of, for those of you who are looking for the basics around where do I go in order to be able to scale this up, and what are my options, and what are the different pieces that I can use to be able to do that, we'll get something out of this. And for those of you who are looking for not just the how do I do this, but why do I do this, and what are some of the strategic things that we can think about as we're going through, hopefully we'll have a little bit of something for everyone. So to start off, everybody knows Tailwind Traders at this point. We've been talking about it in pretty much every session for the last couple days. Our retail store is successful, right? Congratulations, everybody. You've built a business that people are excited about, and customers are coming in, and transactions are being processed. We have growth. We even have exponential growth. The management is happy, and the executives are happy, and the stockholders are happy. And now what? Right? So we've got all of this growth, we've got all of these good things, but now we have the challenge of how do we manage that demand on the back end? Growth comes at a cost, and from an operations standpoint, that cost is how do we manage that on the back end so that we are providing the best experience that we possibly can for our customers. The infrastructure, the application infrastructure that we deployed that got us to that point of being popular, that got us to that point of being successful, is no longer going to keep up with the demand that we're seeing. So we're going to have to figure out what we're doing. The first question that we want to ask as we go through this process is, do we need to scale out our application and the infrastructure that lies underneath it? Is scaling something that we're going to have to undertake? And yes, I recognize that it's the worst answer to any question, particularly from an operations standpoint ever, but that's largely because it's usually the right answer, but the answer is maybe, right? It's not a guaranteed that as soon as we see that growth and as soon as we see the demand on the front end, that scaling is immediately the way that we're going to go, that adding infrastructure, that scaling applications is immediately the way that we're going to go. And why do I say that? We may have things that we want to tackle before we ever start thinking about the challenges and the costs and the overhead involved in scaling. The first is going to be the application itself, right? Is the application buggy? Are we leaking memory? Do we have inefficient queries or calls to the databases? Do we have pieces of the application that we can go through and optimize, or that we can go through and change out from it being this little application that no one was really hitting to where it is now? We've probably learned a lot. We've looked at the analytics for the application. We've looked at how the application performs under load. Maybe before we start thinking about adding infrastructure, we want to go back and make some optimizations to the code itself in order to get better performance or to get more performance out of what we've already put in place. The second thing we need to know is this demand permanent, or is it something temporary? Did we get mentioned on a talk show? Did we get put on the front page of Hacker News? Is there something that is temporarily or artificially driving traffic to the site in a way that maybe we just want to ride it out. Maybe it's not optimal, maybe we're pushing it a little further than we're comfortable with, but we can't count on that traffic being there forever, and so do I want to invest in infrastructure for any amount of time in order to be able to handle a temporary spike? The other thing we need to figure out is, do we already have unused capacity that we're not using? Particularly in a cloud environment, as an app moves through the development phases, there are times where we stand up infrastructure in order to be able to do different parts of, whether it's performance testing or whether it's resiliency testing, where those instances that we used for that, we're already paying for them, they're already running, and they're not being used. So before we go and build more infrastructure or deploy more infrastructure, do we already have things that are deployed that we are paid for that we can move around in order to be able to add the performance that we need in without adding any additional overhead? Here's the thing. Every time we have this discussion, we're going to balance risk versus expense. On one hand, scaling of any kind, every bit of scaling, and we'll talk about this in a couple different places, but every bit of scaling that we're going to talk about today costs actual money. Every time we do something, there's going to be a financial impact to it. On the other hand, if we don't scale appropriately, we're going to give a bad impression or give a bad experience to the customers who are coming in, which holds its own risk. We want to be able to find that balance, and that's going to be different for every business. There's going to be a different risk tolerance for every customer who's out there who's building these things, and then make sure that we're staying where we need to be, both from a risk and a cost standpoint as we go through. Scaling is most commonly used. The answer, if you asked what's the most common trigger for scaling, it's going to be resource exhaustion. After we've gone through and optimized the code, after we've recognized that this is going to be a more permanent load that we're under, that we're just more popular, that we've just grown the company, we're going to look at, when do we run out of resources? When do we run out of CPU? When do we run out of memory? When do we run out of bandwidth? When do we run out of the resources that we have that are finite in there? The trigger for this, and this goes through all of the SRE sessions that you've seen so far, where we're very much going to focus on looking at this from the customer standpoint, and that's where we use the SLIs and the SLOs that Jason talked about in his presentation this morning. We want to look at this as, when is the application no longer meeting the objectives we set for them? When is the application not doing the thing that our customers need it to do? And that's going to be the trigger for, we know that there's a resource exhaustion issue, and we know the application well enough to know that when we get to this point, it's no longer going to perform the function that we need it to perform on behalf of those customers. One thing that makes talking about scaling tricky is back related to that first bullet, right? The resource exhaustion. Load increases are often a combination of anticipated and unanticipated spikes, and it's sometimes hard to figure out which of those we build for. And we've got lots of different tools to be able to manage that, whether that's auto scaling, whether that's being able to bring things up, but we need to be able to factor for both of them. We need to be able to look at both the anticipated and unanticipated load spikes as we're going through and figuring out what type of scaling is going to make the most sense for us. Even if you have good reasons to scale, even if all of your thresholds are met, you know the application, you've optimized it as much as possible, everything that we're going to talk about has a cost implication. And one of the comments, one of the pieces of feedback that I got from yesterday was, try not to look so much like a salesman. And I realized that's because I'm not wearing a hoodie this week. I actually put a sport coat on. So I'm not a salesman. What I am telling you is that everything we're going to do here is going to cost you money. Everything that we do. And so it is possible, as we go through here, when you leave and you go pull down the GitHub repo and you pull down all the videos in the presentation and you say, I'm going to go try this, it is very possible that you are hooking your credit card up to a never-ending flow of expenses, right? We need to know that up front. We need to understand how that works and that risk-reward behavior. But everything that we're going to do, I want to keep your business thriving. I want to keep the application working. But there's always something on the other end of the equal sign. And in the case of scaling in Azure, that thing is going to be a credit card. So let's just make sure that I want to be as exhaustively clear about that point as I can before we go on. When people talk about scaling, we're usually talking about two types. We're talking about scaling up, or vertical scaling, and scaling out, which is horizontal scaling. We're going to talk about both of them, and then we're going to talk about some of the additional stuff that we can put around it. Scaling, remember when CPUs actually used to look like this? Such a pleasant time. Scaling up is simply a matter of taking the resources that are currently running the application and making them bigger. And we find out what that resource exhaustion limit is, and we simply add more resources. We add more CPU, we add more RAM. When we hit a resource exhaustion threshold again, we do the same thing. We don't use an actual bicycle pump, but I promise none of you are going to leave here and forget that image. So I'll take that as a win. The second way that we look at this is scaling out. And scaling out is simply a matter of, rather than adding more resources to a specific instance, we're simply going to add more instances. And we run into that resource threshold again, and we add more instances. We're just going to think of it as adding more boxes into that pool. Now, the important and probably tricky part of the horizontal scaling is this cannot be done in a vacuum. The application has to be aware of it. If we have a front end that's talking to a database, or in our case, we've got a front end that's talking to a product service and that's talking to an inventory service, we have to be able to know what's going to happen when we add more instances in. We need to be able to leverage them from an application standpoint, and we need to know what happens when we take instances out. If we don't have the ability to move that traffic around across multiple instances, then scaling out isn't really going to do us as much good as it could if the application is fully aware of it, and we can add more front ends, or we can distribute the database simply by adding more instances into it. So we have to know how all of the data plays nicely with one another, where we've got copies of it distributed across the back end. We have to know how traffic is going to be handled on the front end. So scaling out is as easy, particularly in an Azure context, as scaling up on the infrastructure side. Scaling up doesn't require us to do anything with the application code in order to be able to accomplish it. Scaling out, there's no magic pixie dust that I can give you that will turn a single-threaded application into something that can scale out across multiple instances. It has to be built into the app. The app has to be aware of it before that's even an option. Let's take a quick app refresher on the Tailwind Traders side. And you've probably seen this in a couple of the different sessions, so we're not going to dig too far into it. We've got a front-end web app. This is being run in React and JavaScript. It's actually an app service, a PHP app service that's running in multiple regions. We've got the product service, which is the products that are in the catalog. This is a Node.js app that connects to a Cosmos DB using the MongoDB connector. So the front end actually thinks it's talking to MongoDB on the back end, but we've got that running on Cosmos. And then the third part of this is the inventory service, and this tells us how many are in stock, right? So we'll show the actual UI later, but it's here's the list of products, and then we're going to pull the inventory to see how many of them we have in there. This is a .NET Core app. It's connecting on the back end to a SQL server. We've tried to give you literally a little bit of everything. And again, all of these are available in the GitHub repo that you can pull down and you can play with, and you can see exactly how we put these together. When we look at the app in production, it's all of the different pieces that have been put together. One of the things that I will point out is that in the GitHub repo, there is a spectacular deploy script for all of this. We've got two different environments that we're going to talk about today. Each of those environments is a single deploy script that runs out of Cloud Shell. It's magical. So everything that you're seeing in here, every database, every instance, every resource group, every application insights instance, all of it was deployed one time out of a cloud deployment script, and it's from a nerd standpoint, it's by far the most fun part of getting this set up was building out all of the deployment scripting that's in there. So let's take a look at the app itself. Big enough for everybody in the back? Yes? Okay, good. We've got two resource groups, and we've separated the resource groups out by function. We've got one resource group that is simply for the databases, and you can see in here we've got a SQL Server and a SQL database, so that's going to be for that inventory tier. And then we've got the Azure Cosmos DB database, which is going to be all of the products that are in there. On the other side of this, and we can see that all of those are deployed into West US 2. On the other side, we've got all of the app or the compute resources. And we've got an app service plan here, and you can look at the app service plan and you can see what type of instances that we're looking at. And then for each of the layers, for each of the sections of the app itself, we've got a different app service. So in this case, we've got a basic app service. We're using small instances. There's one of each one. And you can see that we have the front end. So that's going to be the web UI that we're looking at. We've got the inventory service, and then we've got the product service that's pulling all of the products out of the database. We've got an application insights instance for each of these, so we've got full telemetry. We can pull all of the statistics that we need out of here to find out where we are in relation to whatever thresholds we know that the app is going to start falling over on. And there's what it looks like on the front end. And you can tell that it's an async. It should take an extra second here. We pull up the inventory or the database with all of the products, and then it takes a couple seconds, and then the inventory gets queried back and gets put in there. So it's basically the same app that we've used for all of the sessions. In this case, we've deployed it specifically in a single Azure region, and we don't have any scale out for this particular deployment, only scale up. And we'll look at the scale out here in a second. The other thing I want to point out, and this is going to be a little harder for the people in the back, is everything that we do through the UI, I want to make sure that we also look at how we would do that through Cloud Shell and how we would do that through ARM templates. So everything that we just looked at, being able to pull up the resources that are inside the resource group and then look at the app service plan and be able to see what we're looking at. We can see the app service plan is called a web server farm, and we can look at each of the different pieces that's in there, and we can see what resource group name it is, what app service plan it is that we're running, what region it is that we're running in, all of the stuff from an operational standpoint that I may want to query programmatically, or that I may want to pull into a script and be able to use for a status update page or a status email, any of that stuff. All of it is going to be available from the command line, and I'm just running this right straight from Cloud Shell, but all of that's going to be available from the command line as well. So everything that we do here, we'll try to show if you want to use it through the UI, or if you need to be able to do it through the UI, that's great. We'll always make sure that there's a programmatic way for us to be able to do that as well. So the second part of this is going to be scaling up. So we have this one app service plan. We've got the 3 different apps that are in there. We just want to be able to give them more resources, but the application, let's say this application isn't capable of being able to do horizontal scaling, and we just want to do vertical. It's pretty straightforward for us to do that. And my guess is, I would hope at least, a good many people here in the room have gone through and done this. And each of these is going to be around what sort of cost is it that I'm willing to incur. So we've got different pricing tiers for the app service plans. And you can see that what we're running here is the B1. We can see the included features down on the bottom. We can see the total amount of CPU and RAM that's included with it. And if I want to scale this up, if I want to hook the bicycle pump up to it and just make the resource bundle that I have that I'm running the app against bigger, I can do that just by picking a different pricing tier. And so we can see here we've got the new, the P1 pricing tiers, we've got the S1 pricing tiers, and you can see all of the different things that are in there. One of the included features that we're very interested in at some point is going to be the auto scaling. And if you have an app that you have been scaling up and at some point you want to scale out, or you're in the process of putting that sort of functionality into the app, making sure that you're in a pricing tier, in a service tier that allows that to happen is going to be pretty important. So the current one that we're in would not allow us to be able to do the auto scaling. The one that we're going to change to will. And it's pretty simple to just say, I want to be able to update this. And Azure's going to do the work on the back end. You can see that we've already updated the app service plan. If we look back at the app service information itself, we can see that we changed from that basic one to a premium V2. We've just added those resources. right? We're going to take care of all the instances. This would be, from an operational standpoint, I need to buy a new server from Dell or HP or whoever and put it in the data center and then move the code over, and now I've got more resources. We've just made this a lot easier because we handle the infrastructure side, we handle the server instances, you just get the additional pool of resources. Now, if I wanted to do that programmatically, of course I can. And we can do that again straight through Cloud Shell. So if I want to be able to pull that resource group and I want to look at all of the app service plans, I can see that it's changed. I can also use an ARM template to go through and instantiate that change through whatever mechanism it is that makes the most sense. And again, the same way before, we can look at the same web farm, and now instead of that original one, we can see that the PV2 is in there and that we're using that premium V2 tier that's on top of it. So we saw it in the UI. We want to make sure that we saw it inside the CLI as well. So a quick note before we continue on to the next one. I want to point out again that just because we're scaling up one portion of our infrastructure, in this case, maybe we're going to scale up the web front end, we know that that's going to have cascading effects across all of the rest of the pieces of the infrastructure that the application is using. This is going to apply for both the scale up and the scale out, but for example, having a beefier front-end server is going to mean that you can accept more front-end connections, which is going to increase the load both on the network between the front end and the databases, but then also importantly on the databases. And so again, this gets back to really knowing the application and knowing and understanding how all of the pieces work together, because just scaling one portion of that may end up causing more problems than it ends up solving. So as we're going through and doing the different types of scaling, don't forget to think about those cascade effects from where you are all the way through all of the different pieces of the app. We've got a couple of these that are sprinkled in through here. The Azure Docs site is pretty fantastic. If you haven't had a chance to go out and play around with it, both the Docs site and the Learn, the learn.microsoft.com site have both been maintained by the same group. So it's the actual teams who are doing the documentation who are also building the learning modules that are in there, which makes for really good content. It makes for very technical content. It's not very fluffy. It tries to get straight to the point and provide some good information. The docs alert that I have put up here is basically everything that you could ever want to know about scale up. All of the options that you have, all of the features for the different types of service plans that are in there. It'll give you examples, it'll give you scenarios, it'll give you code to be able to do it programmatically, and in addition to showing you how to do what we just did through the UI. That URL down at the bottom is aka.ms/scale-up-SRE40. The next part of this, we've scaled it up as much as we can, and it's just not efficient anymore. Either we're using gigantic instances that end up costing more than rebuilding the application in order to be able to scale out would, or we've just gotten to the point where strategically we need to be able to have something that's a little bit more sustainable over time, and continuing to buy bigger and bigger and bigger servers is probably not the answer. One of the things that I want to repeat is, I'm sure there's a lot of you in here thinking, this isn't rocket science, right? Particularly inside an Azure context, the scaling up and the scaling out is not extraordinarily hard. I want you to kind of feel and understand and embrace the fact that this isn't scary. There's not a whole lot of moving parts. It's pretty straightforward. But at the same time, understanding, I want you to be able to go out and immediately start experimenting with what we're doing. And so whether you're looking at free tiers or whether you just want to go in and figure out how would I build an ARM template to do this, or how would I programmatically change between different sizes of instances, what we're really trying to do here is make sure that this doesn't feel scary. This doesn't feel like it's too much for you to be able to handle from an operational standpoint. So let's look at the scaling out part of it. So we're back in our app service plan. And if we look at the scale out, we've got a couple options in here that are interesting. The first one, it actually is labeled as an override condition because the default scaling out is intended to be auto-scaling. right? So if we wanted to manually scale this, and we said we've got one instance now of each of our tiers, but if I want to scale that out to multiple instances, it's literally just a matter of moving the slider as far to the right as you want to, and when we get done with that, it'll build out however many more we need. So if we just wanted to double the number of instances that we have, we change it, we hit save, it's going to tell us that it's updating that auto-scale configuration, which technically is what it's doing. It's auto-scaling with a manual override of 2 instances, which gets a little bit confusing because it's going to assume auto-scaling is always what you want to do when you scale out. Again, it assumes that you would love to hook your credit card up to that faucet and continue to pay for all sorts of stuff. In this case, we're just going to add an additional second instance. Right, so we added it, it's done. Did it finish? Yes. And if we go back and look at it, we can now see that what we have up at the top is instead of the 1 small instance, we've got the 2 small instances that are up here. Right, so again, if the application is capable of it, if we have the ability to handle, because we've got lots of different questions now. I've got 2 front ends. Am I going to load balance the data between them? Am I going to send different regions to different front ends? Am I running those in an active-active configuration? How am I tying that back to the database? If the database layer has multiple instances, am I replicating data between them? Am I hot, cold between the instances that are on the back end? Am I funneling everybody to a single database? Do I have any sort of regional considerations, or does the data need to be inside a specific country? Lots of things to think about simply because we went and added an additional layer, an additional set of resources into that from a horizontal scale-out standpoint. Can we do it programmatically? Absolutely. And again, we can go back into that app service plan. We can list them out. We can show specifically the ones that we're looking at. And now our capacity instead of 1 is 2. So if I need to look at status, especially when we get into the auto-scaling portion, if I want to pull a status report to be able to see how many instances am I using at a specific time, I have the ability to go and do all of that. And we can do all of this through an ARM template. Right, so in this case, what we've put up here is that hosting plan. Right, we see the server farms again. We see the total number of workers and all the pieces that are in there. And down at the bottom, we see the tier, we see the name, and we see the capacity. So if I wanted to be able to update this programmatically, building an ARM template to be able to do that with whatever I want that scale out number to be, 2, 5, 10, 50, 20, however many I need, is pretty straightforward to be able to do. So again, some people like to do things through the UI. When we get to scale, when we start getting good at what it is that we're working with and we want to automate more of that, all of that is available on the back end as well. So auto-scaling. Yes, it's easy. Everything that we've seen so far is pretty straightforward about how do we scale and when do we scale. What's not easy is that it still requires a human to be able to do it. What the auto-scaling is designed to do is to eliminate that 2 a.m., we are at a threshold because of people who are buying things in Australia, and someone's got to go add more capacity to the farm. What we want to be able to do is we want to be able to put in place a rule set that tells Azure when to go do the scaling on its own. And we've got lots of different ways that we can put this together, but what we want to be able to say are things like, if my CPU runs at greater than 85% for more than 5 minutes, I want you to scale this many additional instances, but only on this day, right? Or I want to be able to, on Thursdays, because I'm running batch processing, if my memory saturation gets more than 80%, I want to be able to add more instances so that my front end doesn't see any of the additional work that I'm doing on the back end. Right? We want to be able to make it very business friendly. We want to be able to make it very logical. We'd love to be able to put some complexity in there from a rule standpoint, rather than someone getting a phone call and saying, the website is slow or the website is down, we need to go add more capacity to it. So, do you have to use auto-scaling? Maybe. Number one question is going to be, do you know your app? And when we talked earlier, it was, do you know how your app is architected? This one is going to be, do you know how your app fails? Do you know at what threshold the app becomes unresponsive? After it comes back down from that threshold, does it correct itself? Does it come right back into production and everything works fine? Or does it just spiral from that point and require a reboot, right? Or require a restart of that portion of the app service? There are going to be lots of nuances around when do I add more in, and then what happens after I do it, and how does my app respond, and what are the different pieces that go into that? Is there a danger zone, right? How much risk am I willing to tolerate? How quickly do I want to be able to scale these out? There's just going to be a lot of things that are going to be unique to the application that you're putting in there. If you give the app more instances, is it actually going to improve the performance? How quickly? If I spin up an instance right now, is it going to be 3 minutes until that instance is put into the load balancing system and able to start servicing traffic? Is it 30 minutes? All of these are going to be important for understanding whether auto-scaling is correct for you, but also in understanding how it is that we're going to set up auto-scaling. The second one is, we need to know, do you know your traffic? And this gets back to how much data do you have to build the baseline? If we're going to put rules in place, those rules need to be logical based on what we've seen historically. Otherwise, we're just kind of shooting in the dark. And again, we're shooting in the dark with a credit card that's been hooked up to this faucet that can increase the number of instances just based on the metrics that you've given it. Did I mention it's going to cost you money? I feel like I have, but the engineer in me says to keep reminding you. We've built this race car. What we're putting in place now with the auto scaling is the gas pedal, and your credit card is the fuel that we're pouring in there. Also understand that auto scaling is not omniscient. It is absolutely going to have limits. It's going to try to help with as much as it can. We've got lots of good, and especially with the application insights plugged into this, we've got lots of good telemetry and metrics for us to be able to use to figure out what these thresholds are and where we want to be able to place them. But there's always going to be a delay. From the time the rule gets triggered to the time that instance is up and running is going to very much depend on the app. There's going to be a lot of limitations that are in there. This won't be magical. This is just, what's the saying? It's not magic, it's just automation. Right? In this case, we're just trying to automate against a rule set, but it's important to understand what those limitations are going to be. And if you think back to, for those of you who were in the SRE 40 session in that gigantic room on the other side of the show floor, remember to understand the metrics that matter. When we talk about SLIs and SLOs, think about it from the customer perspective, and it's not when does necessarily the app need to be scaled, it's when does the customer need the app to be scaled in order to be able to continue getting the experience that they want. If I haven't scared you away, if you're not just terrified of auto-scaling at that point, let's talk about a couple of the things that are included in an auto-scaling profile. The auto-scaling profiles are going to be these rule sets, all the different pieces that we're going to put in there. The first part that we need to be able to manage is the capacity. And the capacity has 3 numbers. It's got a minimum. What's the minimum number of instances I want to have running at any one point in time? It has the maximum, and those two are pretty straightforward, right? What's the most number of instances I ever want running at a time? And that might be dictated by price, that might be dictated by design, by architecture of the app itself. The one that's going to be new for most people is this idea of a default. Because auto-scaling can use anything as a trigger, because it can be pulling in data from an external monitoring system, it can be pulling data in from an external web service that you've built that's actually doing front-end testing to see what the response time is, and then using that response time in order to be able to spin up more instances. There can come a situation where auto-scaling can't get one of the values that it needs to determine whether a rule's been broken or not. And when that happens, when it says I just have no input, it's going to immediately move to this default setting. Now, the default is interesting because it really depends on your risk tolerance. Some people will say, make the default the minimum, which is brave, because if you're at 50% of your total capacity, you're immediately losing capacity when that happens. Some people say, set it to the maximum. If I don't have my input, make sure that any amount of traffic is going to be taken care of, which is also brave because that's expensive. most people will figure out what that risk tolerance is going to be and are going to be somewhere between 20 and 80%. If it is more important for the site to be available or for the application to be available than it is necessarily to have perfect cost controls when the default kicks in, maybe we move into the 60, 70, 80% populated as the default. If it is more important for us to be cost conscious, even if that means some period of time while we're waiting for that input to come back into the rules, then maybe we look down in the 20, 30, 40% range. It's going to be very dependent on how it is you want to set it up, again, taking into account that risk and cost profile that we're thinking about. The next come a sets of rules, which we call triggers. And the triggers are usually a metric. What do we want to trigger on, plus a statement of how long the metric has to stay over or under that threshold. Once the trigger is kicked off, like once we hit that level, the appropriate scaling action, and we'll see what those look like here in a second, gets put in place. And then the last thing is the recurrence. This is generally, when do we want this to happen? Is this something that can get triggered at any point? Is this something that can only get triggered the first week of a month? Whatever it is schedule-wise that we want to be able to do, and we can have lots of different rules. So we can have different rules for different periods of the year. We can have different rules for different parts of the day. We can make that as complex as we want. I want to give you 3 quick warnings that don't really have to do with the fact that it will cost you money, because I feel like we've covered that one, about auto-scaling before we go on. The first one is it's important to recognize that scaling out happens when any of your triggers are hit. You can have 10 different triggers. When one of them gets met, we're going to scale out. Scaling in happens when all of the triggers are met. So if you've got 6 or 7 different triggers for if I hit any of these thresholds, scale out, we are not going to scale back until all of those triggers are back under their thresholds. So if you have any of those that may overlap or that may feed into one another, my CPU utilization is high, therefore my memory utilization is high, understanding how those triggers work, because it may mean that you never scale back in. Right? So we're going to scale out when any are met. We're going to scale in when all of them are met. And auto-scaling always wins. Remember how we went in and manually said, I want to have 2 instances? Auto-scaling doesn't care. It doesn't know about that. It's not contained as part of its metrics. You can go in and manually increase it, and then as soon as you hit a trigger, auto-scaling is going to increase it again. So just understand that once you turn auto-scaling on, auto-scaling is going to win in the battle between I just did it manually and you're going to do it by rule. So let's take a look from a demo standpoint at our instance that we've got set up and how we're going to set up the auto-scaling. So we're going to go back into the scale up side of things here on our app service plan. Nope. Scale out. And we're going to enable auto-scale. And what this is immediately going to do is it's going to ask us a couple things. It's going to ask us to pick a resource group. And this is, I'm confident that there are at least half of you in here who are as frustrated with this particular feature of Azure as I am. Where in our case, we've got lots of resource groups, right? And they give you this entire list that is kind of ordered a little bit. SRE 40 global AMS. There it is. And we're going to give it a name. 40 AMS. Now, if we look down, we've got some things that we can do. We can scale out based on a metric, or we can scale to a specific instance count. Here's our minimums and maximums and defaults. We're going to do a minimum of 2. We're going to do a maximum of 50. Well, based on this app plan, let's do 20. And then for the default, we're going to pick that midpoint. So we'll do a default of 10. Now, when we go in and add the rule here, this is where we're going to pick the specific thresholds that we want to hit. And in our case, we'll take memory percentage, and we'll take the average, and we'll set the threshold to 80%. So if in average over a certain period of time. We have a memory percentage that is greater than 80%, and it stays at 80% for more than 10 minutes. We want to increase the count by 1, and then we've got a cooldown field here. And the cooldown's important that before we click OK on this, I want to point it out. The cooldown says, after I scale, wait a minute. Because when I scale that new instance, is it immediately going to drop the memory utilization on my existing instances? No, it will not. Depending on the app, that could take minutes, that could take tens of minutes, that could take an hour. I don't want to continually be adding more instances into the pool while I am waiting for the application to use the instances I've already given it. So this cooldown is going to be very dependent on your app, and this gets back to knowing your app. If it takes 15 minutes for a new instance to move in and start reducing the load on the rest of the cluster, then we want to be able to set this to 15 minutes. We're going to leave this one at 5 because for the app that we're using in the demo, it doesn't really matter. But that's going to be a really critical thing to understand when you're going through and setting up the auto-scaling rules. So we put it in, we've got our rule, we've got our instance limits, and we save it. And it's going to update the auto-scaling configuration, and this is going to put that auto-scaling profile in place, and we'll be able to see that here in just a second. And then it's going to go ahead and scale out whatever sort of additional instances that we need. But at that point, basically, we've implemented auto-scaling. Now, we haven't solved any of the rest of the problems. We haven't solved how are we going to load balance that on the front end. We haven't solved how are we going to add new instances that get spun up into the load balancer. Right? Again, there are lots of additional pieces from an app standpoint that we're going to want to be able to put in there. But for the app service plan and for the 3 different pieces of this app that we've now said, when you hit this threshold, this very admittedly basic threshold, we want you to go ahead and scale that out. And if we look at that from a CLI standpoint, it looks much the same way. So we go back into our AZ monitor and we pull the auto-scaling profile for the resource group that we're looking at. And when it comes up, we'll see the representation of all the things that we built in the UI. So we'll see the profile itself. We can see that it's enabled, so we've got the Boolean is enabled, is set to true there. We've got the profile for our capacity, default minimums and maximums, and then we've got the trigger and the scale action. What trigger are we going to meet, and what scale action are we going to have, and what's the cooldown going to be for it? So again, I would very much recommend that you do as much monitoring and reporting as you need to once you've implemented auto-scaling, just to make sure that we're going to send you alerts because, I mean, obviously we've just added more instances, you're going to get an alert for it, but managing this, making sure that you've got a tracking dashboard, making sure that you can see what the scaling is doing over a period of time so that you can better tweak and define those rules is going to be really important. And yes, we can do that with an ARM template. So being able to both implement the auto-scaling on a specific app plan, but then also being able to make changes to it if we wanted to change the timeout, if we wanted to add rules, if we wanted to change the threshold for the rules that we have. It's just a straightforward ARM template that we can implement directly. So again, we can do it through the UI, and it's pretty easy and pretty straightforward. We can do all of the reporting and all of the implementation that we want to from the CLI or from any scripting toolkit or scripting language that we wanted to as well. Our second docs alert is going to be specific with autoscale. There are so many different examples of being able to look at external metrics to be able to use for our autoscaling thresholds, and there's a bunch of really great examples out on the doc side. So that short link down at the bottom is aka.ms/autoscale/autoscale-SRE40. So we've handled load, we've handled resource exhaustion scaling, right? We can do that based on the type of app we have. We can scale it up, we can scale it out. We can let Azure auto scale it for us. We can put rules in place to be able to know when and how that's going to happen. But do we know how to handle localized failure? Do we know what happens if the data center goes away, or if the region goes away, or if I have to evacuate a data center for whatever reason in order to be able to move all of my resources from one place to another? Azure has a bunch of different recommendations around this, and we're just going to run through kind of the high level of what this looks like. The first thing that Azure is going to recommend is being able to place things in different regions inside different geographies. Azure has 52 regions deployed around the world. I sound unsure because it appears that we add another data center every other week or so. We just opened the 2 in South Africa, and we actually did the Ignite Tour event down in South Africa, and they were wildly happy that we were opening the 2 that are down there. So the first thing that we're going to use as a recommendation to handle localized failure is to deploy the app into different regions. Now, Azure has special regions that are paired with one another that we call, in a fit of marketing brilliance, region pairs. These region pairs are interesting for a couple different reasons. One is that all of the region pairs are designed to be able to do things like feature upgrades and recovery in a staggered method. So almost every region that we have has a region pair with it. And between the 2 of them, if we need to do an infrastructure upgrade or if we need to do a core software services upgrade, we're never going to do 2 regions in a region pair at the same time. We're always going to do it in one, and you're going to know about it, and then you can test and make sure that everything works the way it's supposed to, and then we'll stage the updates into the second one. It also happens that same way for things that come back up. So if there were a multi-region outage, we are going to prioritize rebuilding resources and rebuilding customer workloads in one of the 2 regions inside a region pair. So regions are great, and spreading workloads across region is great. We have lots of additional benefits for region pairs, including there's high-speed connectivity between them. So we can do things like synchronous replication between them, whereas between regions that are not in region pairs, you're going to use whatever transit it is that you have from an internet perspective between the 2 of them. So we've got regions as individuals, we've got region pairs as a matched set of database of data centers. And then we've got the availability zones, and the availability zones are going to be within a region, being able to spread things across individual failure domains or racks, or however the availability zone is defined within that region. 54 total. So there are 54 of these total, plus all of the edge locations. There's essentially 140 different countries that we can put things in. I promise you that this slide, in fact, it doesn't have South Africa North and South Africa West on it, so it's already out of date. This is something that is very much a differentiator for Azure, the total number of countries and the total number of regions that we have out there. So if we're going to handle the localized outages, the first of those is going to be the region pair. They're close together from a network perspective. They're far enough apart that they should be able to fail over. The region pair for Europe West, which is here in the Netherlands, is going to be Europe North. So we've got a region pair if it makes sense to have data that is outside of the Netherlands. Right? In some cases it isn't, and that entire app needs to be here, and so a region pair doesn't do you as much good, but the region pairs is going to be the first way that we do that. If you want an updated look at all of the regions and the region pairs and which ones are planned, there is actually a short link for that takes you right directly to the Azure site that shows you what those are. I promise this will be the last time we do this. Do you have to use region pairs? Should you use region pairs? Maybe. Maybe it makes sense. Maybe it makes sense geographically. Maybe it makes sense from a network standpoint. Again, particularly in Europe, there are lots of data sovereignty questions. And it's part of the reason why I think we're up to 4 regions in Germany alone, but that we've got so many different regions spread across different countries, even in a relatively small geographic space, is because the legal requirements that some countries have, or that some apps have, or even just that some customers demand, means that that's going to be important. So are the region pairs important for you? Maybe. There's some more thinking that has to be done to go in there, particularly around, if I don't have horizontal architecture, what's the point? If I don't have a way of managing data consistency on the back end, what's the point? Again, a lot of the things that determined whether we did horizontal or vertical scaling is also going to determine whether or not the region pairs make sense. And even if they do make sense, what does that look like architecturally? Am I going to do active-active? Am I going to do active-passive? What sort of failover am I going to have between them? Data sovereignty issues, all sorts of fun stuff. If we look at it from a graphical standpoint, we've got the geography, in which case this would be Europe. We've got the region pair, which is going to, in this case, be Europe North and Europe West. And then we've got the individual the availability zones within each of those individual regions. So how do we manage this on the front end? And that's where we're going to talk a little bit about front door. We talked earlier, we've got lots of different public or lots of different web front ends. How do we manage the traffic that's across them? And this is where front door just came out of preview, I guess maybe a month and a half ago. Have any of you used Azure Front Door yet? All right, there's a couple in here. This is the global HTTP load balancer that manages all of the failover between those instances. And this is distributed across all of the Azure regions, and it's a service that runs rather than an individual instance that runs inside a resource group. It has a couple bonuses. The full application offload and application acceleration. It's got, because it's distributed and because it's an Azure service, we put some DDoS protection in there that you wouldn't necessarily otherwise get. It's got a full centralized control plane so that we can do out-of-band traffic management and orchestration. If the interface is saturated, if there's a DDoS in place, we always have access to that centralized control plane. And it gives us actionable insights. So it's using all of the same telemetry technology that the rest of Azure is using to be able to pull out what's going on there. We picture this. We're sitting in a cafe. We've got a bunch of the team that's sitting down. We're trying to figure out what this is going to look like. And we say, okay, if we're going to distribute this, if we're going to make this horizontally scalable, here's what we want it to look like. We've got users on the front. They're coming into the front door. We've got our front ends and our inventory and our projects. We've got all of the back ends that are looking there for both the databases on the SQL side and the databases on the Cosmos side. ASP is App Service Plan, not that other thing some of you in here are old enough to think about. But this is what we want it to, this is what we want it to look like, and we want to plug it into App Insights. We want to use Azure DevOps to be able to deploy across the different regions. We want to connect DevOps pipelines to be able to do that deployment work. And this is great, right? We all kind of circle our heads around and say, as an operations team, this is what we want to do. At some point, we have to make it pretty for the people who wear suits. And we can't do sketches on napkins, so we build them an actual layout for what we want to do, and then we start comparing it. What is it that we have, and what is it that we need? And when we build this out, we've got everything except two pieces that are on here. We don't have the redundancy between the Cosmos DB, and we don't have the Azure Front Door. Everything else we can stage the deployment of through Azure DevOps. So in this case, this is where we're going to focus. We're going to add Azure Front Door into the demo that we just looked at. And we've got 7 minutes, so this is probably going to work out just about perfect. So if we go back to our dashboard, this was our single vertical scaling app. The other one that we deployed, and again, the script to be able to do this is all inside the GitHub repo that we'll give you the link for here at the end. We've added a couple extra things. So you can see on the DB side, we still have the one, Cosmos DB, because the Cosmos DB, making that regionally redundant or even within a region pair is pretty easy. We've also got the SQL databases and the SQL servers that are hosting them, and we've set those up inside a replicated environment, and they're doing an active-passive failover, and everything works the way it's supposed to. On the app resources side, we now have a primary and secondary for everything. We've got a primary front end, we've got a primary inventory and a primary product, and we have two different app service plans, one for the primary side and one for the secondary side. The front door is pretty straightforward, and part of what I like about it is that it gives us a pretty easy interface to be able to decide what is it that we want it to look like when we build out the environment. Let's back up a little bit here. So we go in, it's straight out of the marketplace. It's called Front Door. The beta version, the preview version was actually called Front Doors. It was plural, and nobody could search for it, and it made it a lot of fun to tell customers, no, it's a real product. It's actually fun, and you should actually use it, but I know you can't search for it. Again, we get our gigantic list of resource groups. And we pick the resource group that we're going to be building this out of. And when we go into next, it's going to give us a pretty cool graphical interface to be able to lay out what it is that we want to do. The first thing that we do is we put the front end hosts. So however many of these front ends it is that we want to have in here. And yes, all of this is deployable through an ARM template. So if we wanted to set up something that said, alert me when auto-scaling adds more instances, and then immediately script adding those instances into the front door group, the front door front end hosts group, we can absolutely do that. But we pick what we want to use for the front end hosts. We add the back ends in. So we're going to add all of the web servers, all of the web front-end servers that we have in there, everything that's going to be responding to requests from customers. Again, you get a gigantic, this time not alphabetized list of instances that you want to be able to use, because that's even more fun. And then we tell it, what do we want to listen on? What ports do we want to listen on? Do we want to set priorities different? Do we want to look at different pieces for what we're doing? Giant list of instances. We pick out the one that we want. And then the last thing that we're going to do is we're going to build a rule set. And the rule set is simply going to say, how do we want to route the traffic? And this is where it can get really complicated, and we'll put a docs link up here at the last second to be able to look at what the rule set options are. But once we've got the backend pool that's in there, and we set up this routing rule set, we just say go. And it's going to go out into Azure, and it's going to deploy this, and it's going to distribute that configuration across all of the different places that the Azure front door service lives. And then at that point, we're done, right? We've built the load balancer. We've built the rules on the front end. Every bit of traffic that comes into that load balancer where we defined that front end host, and you can see the URL for that, is going to, in this case, 50-50 round robin between those two hosts. And that's where if we had multiples, we could set that differently. We could designate primaries and secondaries. We could do all sorts of fun stuff that was in there. So we go in, we deploy it, and now we've got 3 basic URLs that we can use to talk to the service. We've got one that can talk to the web service primary, we've got one that can talk to the web service secondary, and then we've got one that talks to front door. Look at that. Deployment is complete, and it only took 44 seconds. I've seen them take longer. So we've got everything set up, and now we can go through and do whatever sort of failure testing. We could have a chaos agent running in there that is going to bring down app services randomly to make sure that our failover is working. And we were able to tweak how long that failover is going to be and what it's going to look like. So we can bring up each of those individuals, and we can see that the web instance is there. And then in order to be able to test that, what we're actually going to do is just shut off one of the web instances. And shutting off the web instance actually makes it come up and it says, we don't have, this instance has been shut down, because Microsoft gives you the nice, pretty front page that says this app service isn't running, rather than just coming back with an error. The app service is stopped, and we look at the primary app service, and it says, no soup for you. And we get a 403, and now the load balancer on the front end is kicked in. And so whatever that timing is, we're going to see that when we look at the load balancer is going to come back and say, I tried to hit that front one, and it didn't work. The rule kicks in. It changes the traffic pattern. In this case, we've only got 2 of them, so it's going to direct everything to the secondary. And then the pattern comes back up. So we've got a stopped instance, we've got a running instance, and we've got a front door to the customers that they're using that is going to be able to always return a valid instance across all the ones that we've scaled out to. Yes, we can deploy this via ARM template. So we've got all the pieces that we need to be able to deploy that via ARM template. And here's the docs alert. So front door -SRE 40, there's so much stuff that can be done in here around different scenarios and rule setups and how we're going to configure the front doors and those sorts of things. So it's definitely an interesting, one of the more interesting products I think that we've come out with here in the last little bit, particularly on that networking and security front end side. So where could we take this going forward? Some things that we could look at for possible directions for scaling as you're building out these apps. Once you've got the scale up or scale out, how you want it to be able to work, then we can start looking at CDNs. How do we get data closer to the customers that are in there? Azure there is an Azure service for this. It's really worth taking a look at if you haven't already. We can talk about failovers. We can talk about how do we add additional rules to be able to do both planned and unplanned failovers there. We can talk about traffic shaping. Do we want to take traffic from specific regions and be able to send it to data that is in specific regions so that we're not having to cross lots of distance and add latency in from our request standpoint? And then do we want to drain data centers? How do we get all of the data out of a specific facility, whether it's because we have to or whether it's because nobody is going to talk to the UK again ever? Whatever the reason is, if we need to be able to evacuate a data center, that is just an exercise in scaling. In that case, we're scaling to 0 in one place and need to be able to pick up that elsewhere. If you want any of the presentations, the lesson plans, the session, the GitHub code for this, the links are up there. These are the same codes for all of them. And there's a booth down in the hub that will actually let you go down and email yourself any of the presentations. So there's a section downstairs that will give out all of that information to you. If you haven't looked at SRE 50, Emily Freeman is presenting this afternoon. It's kind of the philosophical side of how do we fail, how do we look at the different things that happen when a failure occurs and be able to manage that. And then the last thing is, I said this yesterday, this is the first time we've done the learning paths. This is the first time we've said, here's a curated set of sessions to be able to help you with the questions or problems that you're dealing with. The more feedback we can get, the better. Even if that feedback is, this guy says maybe way too much, that's fine. Take 30 seconds if you don't mind inside the app and give us some feedback so that we have the ability to deliver better content for next time. And that's all I have. Please enjoy the rest of the afternoon and thanks for coming.